Okay, now it's the second topic. The next topic is about education. In this presentation, I'll talk about how Lego-based project can innovate the systems engineering education. And also it has something to the Industry 4.0 or new industry, the revolution or something. Okay. Before I talk about the main topic, let me share my research philosophy. For when I select the research topic, here is my method where obviously there are several different ways of selecting research topics. Obviously, the most typical ways is that ways are get the topics from the other person's journal. So at the back end of the conclusion section, then there is a future research, right? You usually put, and then you get some ideas, and you attend the conference, and you get ideas, right, from other colleagues. But for my case, I try to actually solve the problem by working with industry and provide the solution. And then after that, try to find any academic implication and then do the research. That's my approach. Of course, it's not really, it's really challenging. Well, you have to understand the industry problem and also provide the solution, and you have to prove that, and then you have to deliver the result, right? But I think that the approach has a lot of meaning, okay? And also another philosophy is that try to innovate, find a new solution, the new area as well. So of course, you work on the area already defined, but it also has value, find another area in the research, okay? So in that line of philosophy, we do a lot of industry cases in my research lab. So for example, you know that this is the most famous sporting fashion brand in Korea. So we've been working with the company for 3 years, and we provide a solution in distributing. Basically, we try to decide which product has to be allocated to which store. Well, in the past, that is based on experience, right? But we use the advanced algorithm with the data analysis. So we developed the system, and then actually the companies are using the system since the last year. Okay. By the way, the article indicates that it's just simple, but it's not simple. Okay. All right. And also we are working with one of the biggest automated material handling system provider in the world, actually. And then we co-developing a system. So this is hardware, and also we are developing logic. The logic is based on the property of the system. So we try to extract those characteristics and then extract this one, and then also integrate this to the logics, right? So this is currently we are developing right now, okay? And we have a lot of other projects, okay? The reason I bring up this issue is that the lessons I learned from those industry projects are, it really provides a good motivation to students, right? So graduate students, they are working with the industry, and also they feel that they are doing something good, right? I have one graduate student here. So he's also working with the Samsung heavy industry as well. But anyway, doing research in this approach, I really like it, and also students, I believe the students also like the approach. Of course, they have a larger burden because they have to provide the actual solution. But still, give a chance to understand how theories can be applied in practice, and also there's a lot of benefits. But the question is that, what about undergraduate students, right? Because we can actually send out all our graduate students, the undergraduate students to the field, let them solve the actual problems, right? It's not possible because we have to deal with a more number of students, but also at the same time, undergraduate students, they don't have enough skills, even though they are smart, but they don't have enough skills to perform actual work for the industries, right? That's why I developed a Lego system here, okay? Before I talk about this one, let me talk about the systems engineering. So according to the IEEE Systems Council, the systems engineering is the process, is a methodology for integration of multiple disciplines to achieve a system level, okay? So the applications areas or domains are like manufacturing system, supply chain, and also automation system, transportation. Basically, they are large-scale systems. You can get the idea, right? For these days, in the era of big data, the recent IT and data-oriented industry trends, they emphasize that the role of the data-oriented decision making is emphasize that, right? So for example, like a IEEE Systems Journal or the II transactions, well, last a couple of years they had multiple special issues about data-centric approaches, something like that. So which means that in the research area, into the systems engineering, data-oriented approach becomes really a hot topic. Right? Okay. Basically, we are using those, the data analysis as a tool. So basically, where we collect data and also analyze data, make decisions, and then apply that to the domain, right? So the focus is not just developing the methodologies, but also to use those methodologies to the domain areas. And sometimes they extract the characteristics and properties in that domain knowledge, and then they use that as the algorithm to improve the methodology, something like that. Okay. But there are some issues in education, right? The first one is that you know that we are pretty good at teaching individual component. So for example, where the probability, it's a probability, just forget about anything, where the rest of them, just probability is probability. We teach the probability, right? And then we teach statistics and also optimization, modeling simulation, database and computation. Well, we teach them as independent issues, okay? But the thing is, in order to solve the actual problem in the field, then more holistic approach, especially in systems engineering, we need to do that, right? Another issue is that the hands-on experience is really critical and crucial in the education. So I found the following statement in a journal, right? Let me read through that. No matter how many concepts you teach, no matter how deep you go, no matter how tough your exams are, the only lessons that will remain in the students' minds are those that touch them, right? I agree with that statement, and I also find a similar statement in other journals as well. So therefore, well, for example, like a mechanical engineering, they provide a laboratory, the environment for like a fluid mechanics, right? And the control theory, where we can set up a laboratory environment. It's more like a control environment, right? So you perform the experiments, right? But the problem is that in our domain, systems engineering, we have to deal with a large-scale system. So it's not easy to provide the large-scale environment in a universities. Okay. Well, simulation is often used to overcome this issue. So the simulation is often used in class to provide a virtual domain system. However, the pedagogical benefits are limited. I also got this from this journal. And also I found similar research they agree with that statement. Okay. It doesn't necessarily mean the simulation is bad. Actually, simulation is really good. Simulation approach is really good, but there is a limitation. That's what I'm saying. And also teaching data issue, where basically what I'm trying to say is that we have to also teach which data should be collected and how they should be processed. Those are really critical decisions in actual problem solving. Okay. However, without access to an actual physical system, well, which is most often case in the traditional education environment, students have little opportunity to learn or understand those decision processes, right? So therefore, unless you don't have the physical systems, right, representing actual domain, then the pedagogical impact is limited. Okay, that's why we developed a Lego system. So I named the KAIST Lego manufacturing system. It's a picture of the laboratory. Accidentally, the name is actually same as the KAIST learning management system. Okay, so it's different. We call it KLMS. Okay. Okay. So we use the Lego Robotics kit. Okay, it comes with a actually small computer running on the Linux, and the multiple sensors and also actuators with basically motors with encoder, and also it comes with software. But the software is also the works with MATLAB, the Java or C++ and any other languages. So the connectivity in terms of the software that's pretty good, provide good environment. The using Lego in education is nothing new, especially robotics and also mechanical engineering, electrical engineering, control theory, where Lego has been used widely. But I haven't found any research or report applied in the system level engineering. Okay, so I found just one report. The philosophy of that the system is that we try to provide a holistic environment to teach that. So instead of just teaching one by one, we try to teach that one entire concept in just one the domain, which is the manufacturing, and also try to provide the solution. I mean the experience of problem solving using Lego. Okay, so far I developed several different projects. Okay, so let me just focus on. Let me spend about 5 minutes about this one. So production line improvement. So this is the Lego system. Okay. So the Lego system, the circle is representing the part, and then the machines are holding a part. They imitating the behavior that the machine is processing. No physical processing is done in here, but it just hold a part. Right? But still, well, you can capture the key characteristic you can capture in the actual manufacturing line. So the line consists of 3 machines and also the conveyor belt and also automated systems and multiple sensors. So a team usually consists of 3 to 4 students working on the systems, and also their mission is to improve the performance of the production line in a logical and scientific way. So in order to do that, but I just give that make improvement. I don't give any direction. That is a really open-ended question, right? So therefore, they have to define what the improvement means. Okay, is that increasing the production rate, or the cycle time, or the work in progress inventory, or any combination of it? They need to find out, right? So that's their mission. And the analysis is that the data collection, and they need to perform the statistical analysis and understand the relationship between those performances. Okay. So therefore, they need to answer the first, what is the problem? Okay. And then after that, what decisions should be made about the problem, and what knowledge or information is needed to make the better decision, and how should data be collected, and what data analysis is needed to convert the data to knowledge, right? So therefore, usually when we teach that, we teach each subject as a silo, right? But instead of doing that, we have to actually think as a top level and going down level. That's a little bit different, okay? So in the sensor analysis, you need to collect the data and also filter, which filter you need to use, how to collect the data, you have to think that way, and also how to store the data, right? And also what kind of data analysis we need to perform, and also you need to actually select appropriate analysis methodologies, okay? And also eventually, you need to improve the system, then you use the modeling, right? So modeling is the process where abstracting the physical system in a high level, more like abstract level, right? So that in that case, then you will experience how to make assumptions and how to logically prove that your assumption is appropriate, something like that. And then eventually you come up with optimization models, right? And then when develop the algorithm, then you have to extract the property, and then how to use this property and characteristics, and then they implement algorithms, right? So you have to go through that thought process. So I've been using this one, and then here 215 and 216, and then here is the class assessment. Okay, so I taught this class 2012. At that time, I didn't use the Lego, and then the year 2015 is the first year I fully deployed the Lego manufacturing systems in the classroom. Right. I usually give out the 4 exams. The first 2 exams, they don't have anything to do with the Lego. Okay. So as you can see those 2 exam scores are pretty much similar, which means that the level of students are the knowledge level of students are pretty much similar, right? But the exams related with the Lego, well, you can see that there is a high improvement in here. The improvement was done. That was because that the students with a low score on this one actually had higher score, right? the good students are still good, right? But the bad students actually, they made a really good improvement. Okay? That's what I observed in here. Okay, it doesn't necessarily mean that it's a really impact or it's a. Well, let me put it this way: there are lots of assessment techniques, and this is just one of them. So I don't want to conclude that that indicates that the Lego-based system is a really good approach, but it means something. Okay, it means something. And the class evaluation, you know, that was really bad, but it was good actually. The survey result was that a lot of students actually complained about it. Well, I spent too much time with the Lego, but the number was good actually. I was a little bit surprised. Yeah. Maybe you guys need or enjoy the torture, maybe. Yeah. The one thing I'm currently working on is that there is a theory, constructive learning theory, right? It indicates that the knowledge doesn't necessarily mean that you just understand the specific concepts, but also you understand the interrelationship between those concepts. That is the constructive learning theory, right? So before they actually performed the project, or let them actually make a. Let me put it this way, I did a survey, right? So if one concept is related to another one, they actually give a certain point. And if you believe that one concept is not related to a specific concept, then you give out the low points, something like that. And then after that, this is what I found. So this concept actually, first one is the concept of the manufacturing, second one is the statistics, and the last one is optimization. You know that you can see the connection between those interdiscipline, right? That's before they do the project. But after that, well, I found that certain the connections within actually between the domains. So I'm still investigating the meaning of this one, but I found it's pretty interesting. Okay. By the way, I'm not an expert, but there is a area, educational psychology, about the structural knowledge. Okay, so this is my future direction. We're also developing a system. It's a more complicated system. So reinforcement learning. So try to learn by self. I've been working this for several months, but still working on that. Okay, I try to deploy that sometime next year. Okay, so basically it imitates the material handling system used in semiconductor fab. And also eventually I'm trying to use the Lego for the flipped class or education 3.0 format. So for the lecture or the knowledge, I transfer it through the online systems, and then in the class, let students play with this one and then have discussions. So I try to convert the entire class in the flipped class format. Okay, so this is the conclusion. Okay, I tried to spread the industry and academia. Well, recently I was invited to deliver a keynote speech in an education conference, and also the tutorial sessions in international conferences. And last week I was invited to the Tongji University and University in Shanghai to deliver a speech about this one. So the people were found that it's interesting. Okay. And also so conclusion is that new teaching method is needed in the new era of big data. Okay, so I propose that. And on the system level, on holistic perspective can be effectively taught with Lego. And also try to provide a new direction for a new teaching concept in the era of a flipped class or something. Okay, so I would like to thank to the department. When I first proposed that idea 4 years ago, everybody was saying that I was crazy, but the department head, Professor Taegli, actually supported that idea, and he actually provided me with the small funding to start off the project. But now, well, I get money from the other companies, and so the laboratory becomes bigger and bigger. And also, by the way, LG and Deloitte are also using the technology, the Lego approach to train their employees. Okay, and I have a couple of papers produced out of that thing. Okay, Thank you.